Hi guys, welcome back. Today we will learn further about the stepper motors, and today we are going to use the PWM with the stepper motor. In the previous tutorial we saw how to control the stepper motor using a driver, and today we will continue with the same wiring. So if you haven't seen my previous tutorial, just watch my previous tutorial. First, in that tutorial I explained everything about the circuit of the stepper motor and the stepper motor itself, and today we are going to program that stepper motor with the PWM. So previously we just saw that how to control it, so let's get started. So first of all, I'm going to create a new project. So go into the computer. In the C directory, here we have nRF SDK. Go into the examples folder, then go into the projects, and today we will copy the previous code from the common mode. So I'm just going to copy that because we are going to use the same code, but if you haven't seen my previous tutorial, just watch it, and then you're going to know how it works, and then go into this folder, and here if you're using nRF52832, open PCA10040. If you're using nRF52840, then just open this PCA10056. So I'm using nRF52832, so I'm just gonna open this PCA10040, then go into the blank, open the SES folder, and then open this EM project file. Here you can see we have some previous code here. Let's start from the beginning. So I'm just gonna remove everything, and then we will start from the beginning because I want my users to know how everything is working. So let's start it from the beginning. So let me zoom in a little and let's get started. So make sure everything is included for this project, and if you haven't seen my previous tutorial on the PWM, if you don't know what the PWM is, just go and watch my previous tutorials for the PWM. The link is in the upper right corner of this video. Just watch these PWM tutorials and then come back to this, because this is the advanced topic. I have already discussed everything about it, and right now we are just going to program the stepper motor. So let's get started. So first of all, let's define some values. So I'm going to set the top value. For that, today I will set this to 1800. Why I'm setting it to 1800 instead of 10,000, I will let you know when I'm driving the stepper motor. As M-top defines the frequency of the PWM, so once we have finished the code, I am just going to explain that. The next thing is we have to define the pins where we have connected our motor. So the first pin is motor step, which is connected with the pin number 22. The next one is the motor direction, which is connected with pin number 23. And the last one is enable motor. It's connected with the pin 24. Next thing is we have to define an instance of the PWM. So this time we are using the hardware PWM. So for that, so for the 0, it means I'm using the PWM instance 0. There are 3 instances for the nRF52832, and if you are using nRF52840, you have 4. I have already explained this in the PWM tutorial. So the next thing is let's define some other constants as well. And here I'm just going to give it a 1 value. Why I am just creating a single sequence value, you will get to know it, because right now we have to control the number of PWM waves that are going to the pin, because these number of waves are going to define how much the motor is moving. For example, if I give it 200 waves, it means the motor will rotate up to 360 and it will complete its one rotation. So this matters a lot, so we have to be careful with this one. I'm just creating some extra variables. We will be using these. We will use these variables later on. Also, let's create a flag. Okay, we have created some variables, and now let's initialize the PWM. First, create a PWM handler. So this is going to handle the number of waves, so it's very important. So I'm just going to use this handler. First, let's create the main function for the initialization of the PWM. Now let's give it sequence values. So I'm just going to define. I have just created an array of one variable, so it's just a simple single sequence value, and I'm just going to assign it the step value. So basically what I'm doing here is I'm just assigning it this step, and it's half of the m top, which is the half of the frequency. So whatever this frequency is going to be, like 100 waves per second or 1000 waves per second, for the half of the time, which is 900 for the 1800, this for the half of the time there is a logic high state, and for the half time it's going to be the logic low state. So for that I have changed these variables according to that, and I have adjusted this 1800 because this is the fastest frequency that can work with the driver to rotate the motor, because the motor does not have any inertia with it, so there is a limit to the initial frequency. So this frequency is good, and the motor rotates at a good speed, so I have selected this. Okay, next we have to define the configurations. So I'm just going to use 2 pins. One is the LED and is the common mode, so whenever the motor is running, the LED is also giving a state, dim state, so it's just an indicator. The motor is receiving these PWM waves. The second pin is the motor, and it's the motor step pin. And I'm not going to use the other 2 pins, so I'm just gonna call this. And for it goes same for the 4th pin, so I'm just gonna remove that. I'm just gonna add that. So the next thing is I'm just gonna give it some lowest priority, because we are not using we don't need any high priority task for that. I'm gonna use 1 megahertz clock. Okay, the PWM is configured, and make sure you don't put the comma here. This is the last configuration, and now we are going to initialize it. So okay, it's initialized, and the next thing is we have to create a simple play function which is going to play these PWM values. Okay, we have configured it, and we are not going to repeat these values. This is a simple sequence, so it is going to load the same value again and again, and now we have to mention for how many times we want to load this value. So for that, and since we are using this stepper motor, and right now it's configured for 200 wave, if we give it 200 pulses, it's going to move a full 360 degrees. So I'm just going to say repeat it 200 times. And the last thing is we have to pass it the flag, which is going to tell if we have to loop or not. So here we are using this nRF5 flag loop, and once this 200 values, once this sequence is finished playing, it's going to generate an interrupt after 200 pulses. So let's go into the interrupt now, and let's do some settings here. I'm using the flag loop here because I have set another variable as a counter variable, and it's going to count whenever this event is going to occur. So it knows how many rounds this motor have moved up till now. So we're going to use this rounds counter, and we will increment it. We have initialized it with a 0, so we are going to increment it. I want to display a message on the log as well, so I will be using the log. Here I'm using the spin rounds as the number of rounds we need to spin the motor. So for example, if I want to spin the motor for 12 rounds, I'm just going to change the value of the spin rounds, and it's automatically going to check against that, and then it's going to spin for that number of times. So here, once it has reached its condition, like if I said move 12 rounds, so once the spin is equal to 12, the round counter is equal to the 12, which is the number of spins of the motor, then I'm not going to use its error output, so I'm just gonna use the void, and I will use the function which is to stop the PWM. Here I'm going to pass the instance of the PWM, and I'm just going to pass here a true value, and the next thing is I have to pass a true here because it's going to wait until it has stopped the PWM. So it will wait until it stops the PWM, then it will exit this line of the code, and I will set the condition of the motor being rotated to false, and I will set the round counter to 0. So whenever a new round is given, it's gonna start again from the very beginning. It's very simple, so I guess you are getting all the logic of this code. And okay, so the next thing is now we have to initialize the log, and then we will call these functions in the main, and then we will start running our motor. So for that, let's initialize the log by making a simple function for the log initialization. If you don't really know about the log, just see my logger tutorial, and you will get to know the basic information for this one. So I'm not going to explain this code here. Okay, coming to the main function, first of all we will initialize the log. Let's initialize the pins for the direction control of the motor. So this is going to control the direction of the motor. So changing the logic on this pin will change the direction of the motor. and I have also connected the enable pin. So the enable pin is very special. So this enable function is very good, and it's very helpful in energy saving, but I will explain it once we have finished our code. We will do a small experiment with the motor and how we use this enable function. Now let's set the pin so that it's we know the direction of the motor. So upon setting, we will see at which direction the motor is rotating, and we have to initialize the LEDs because we want to see that we want to see the LED as well. So let's initialize the LEDs. Now we will initialize the PWM with everything, and let's give a simple message that the application is started. The next thing is we have to define some functions which will be usable for rotating the motor in clockwise and anti-clockwise directions. So let's write those functions, so we can just simply call these functions and move the motor in any direction for as many rounds as we want. So for that we have to create some function. So this is the variable, and we are going to pass this, and it's going to set this variable, and the motor is going to rotate as many times as we want. So upon clearing the state of the pin, that is upon setting the logic 0, the motor rotates in the clockwise direction because we are giving the logic 0 on the direction pin. Now this is the spin rounds. We are going to set this. So now the number of spin rounds are set as the user has sent them. So this is going to manipulate this stuff. Now we will call the PWM play function, and since I'm using them here and the PWM play function is below, so for that I'm just going to declare the function here after the variables. Okay, so the next thing is we are going to set the motor rotating flag to true, because now the motor has received some rounds and it's playing, so it's true. So this is for the clockwise direction, and for the anti-clockwise, let's create the same function. Let's create a similar function. And it's going to be similar, just we have to change the direction. Okay, the clockwise and counterclockwise rotation functions are clear, and they are finished, and event handler is done, the PWM play and the log initialization. Okay, everything is done. So now we can perform some functions here. So I'm just going to remove this first. So let's say I want to rotate my motor counterclockwise for 3 rounds, and I will enable the pin. If I don't enable the pin, the motor is not going to run. So to enable the pin, we have to set logic 0 on the enable pin. And now we are going to use this motor rotating flag, because it will stay here until the motor has stopped rotating, and then we are going to disable the motor by setting the enable pin. Okay, so the motor is going to rotate for 3 rounds and it's enabled until it's moving, and once it stops moving, this flag becomes false, and the program jumps to the next step, and in this step it disables the motor. So what is the function of this? So when the stepper motor is enabled continuously, the stepper motor gets heated up because it has a specific torque, and we cannot move that motor. So I will show this to you once we have finished everything, and it's going to save some energy as well. And of course, once we don't use this enable function, we just set it as enabled forever, we can still use the motor. So we will see, if we continuously put the motor in the enable state, the motor has a braking torque, so the motor is unable to move, and it's useful in some cases. But if it's not useful, then I would recommend you to use this method to enable it and use it. Once it's finished rotating, just disable it if you're not using the braking torque mechanism. Okay, and we will give some delay. Now let's do the same stuff, but this time we will rotate the motor in clockwise direction. And let's say I want to move the motor for 1 round in the clockwise direction, and the one during its moving it's enabled, and once it stops moving it's disabled. Okay, everything is set and good to go. So let's build the code and see if there is not any mistake. Oops, we have mixed up something. Yes, we have made a little mistake here. Let's build this code. I forgot a comma here. Let's see. We haven't added this delay file, so let's add it. Okay, it's done and it's finished. So we had made a couple of little mistakes and it's finished now. Sorry for the mistakes. Okay, right now we are just going to test it, so make sure your device is connected. So we haven't added any delay here, so let's add the delay. Okay, we have added the delay, and let's change the counterclockwise and clockwise direction. So okay, we are going to use this clear for the counterclockwise and this pin for the clockwise direction. And if we set this pin, it's going to rotate the motor in clockwise direction, and if we clear this pin, the motor is going to rotate in anti-clockwise direction, which is the counterclockwise. So everything is finished. Let's build the code. Okay, make sure your device is connected. Click on the connect, erase all, and then download it. And here you can see we are moving the motor in counterclockwise direction for three rounds and 1 round for the clockwise direction. So here you can see one thing, that once the motor finishes moving, I can move it here. It's free to move. And if we don't set these pins, for example, let's comment this code out. Build it, connect with the target, erase all, and download it. Now you will see a difference here. The motor, even if it's stopped, it cannot be moved because it has a rotation, it has a torque, and it does not move, and it's in a braking position. It's locked whenever the motor stays in the enable state, and it's locked. So this is quite useful if you want some braking mechanism in your motor. This consumes energy, and it also heats up the motor, so it's up to you. If you want to do that, it's perfectly okay. There are many applications that use that as well. And if you don't use this functionality, like you don't want your motor to lock when it's stopped, then use this simple enable and disable technique. And with the help of this technique, you can save energy as well, and the motor is not going to heat too much, and it's also going to increase the motor's life as well. And that's it for today. I hope so you have learned something new today. I will put a link in the description of this video for this code along with the information, and you can check it out. If you have any questions, you can ask me in the comments below. If the PWM is somewhat confusing for you, just go and watch my previous tutorials. If you are new to my channel, please be sure to subscribe to my channel. Hit the like button if you like this video. I put a lot of effort in making these videos, and please be sure to support me, and I will be bringing more great quality content for you guys. And in the future we will cover the Bluetooth as well and all the stuff, so make sure you subscribe to my channel. And thank you very much for watching. See you in the next video.